Okay, so hello everyone. Thank you for being here. I was not expecting so many people to be at the last talk of the day. So my presentation now is going to be a little bit, well, actually not so much different from what Andrei showed. It's going to be more of a sciencey talk, right? It's not specifically tied to any language or any technology. It's more of an ideas talk. And there's a very good reason why I said in JavaScript, and it's so I can hook you in, right? So basically this talk is effectively about traversing graphs and calling functions along the way. It's also about writing fancy titles so people think you're more clever than you actually are. So about me, my name's Bogdan Bugarschi. Everyone calls me Boogie. You can find me on Twitter and on GitHub or GitLab, primarily on GitLab. There isn't much to say about me. Sorry. Yeah, I'm also a very heavy breather. I can't, I cannot help it. Huh? Okay, I think I'm good. Yay, no more heavy breathing on the video. Fantastic. I was actually hoping for that to happen because I like the attention. So, finite state machines, what are they? Well, they're like machines with like a finite number of states, right? It's like this, right? It's a turnstile. Does this work? We just need this one, the laser pointer. I'm fine, just need the laser pointer. So this is what a finite state machine looks like, right? This is for a turnstile, right? It starts off locked. When you push the thing and it's locked, it doesn't do anything. When you pop a coin in, then it goes into unlocked. If you pop another coin in, it stays unlocked. Otherwise, when you push it, it goes back to locked, right? Fair enough, right? You push it, something happens or something doesn't, right? But we don't really make turnstiles, do we? Right, so let's think about something slightly more advanced, or well, not really. Let's think of something that, for example, does login, right? The simplest login system in the universe, right? We have a function that starts off in the check login state, and if you give it the proper login, it goes on the valid path and logs you in. Otherwise, like shows an error, right? So this is like with two circles means it's an end state, and so it's done. Basically, you can model this in like code with just a simple if, right? You get the state, you check the username and the password, like this could be a request or whatever, right? And if it's valid, right, if it goes here, then you return some login related stuff or like the main page or whatever. Otherwise, you show some error stuff, right? Simple enough. But in reality, it's not really that simple. You generally get stuff like more complex state transitions, right? Like you load some stuff from a cache and then you like check some valid versions and whatever, and then eventually you do a login if all of that's true, but otherwise you like show an error, or show the login page again, or like show an error or something if something's invalid, right? This isn't actually a real example yet, right? But let's see how you do that stuff, right? Well, you'd load some stuff from cache if the state is there, right? Then you validate the version, then you validate the login, and then you show like the main app. Right? This is actually a lie, right? Because it's bonus complication, right? This shit can be async, right? This stuff can be async. This stuff's like most likely async as well, right? Because you're checking against the database or something. So it's like way more complicated than just a simple set of ifs. Plus, I show like none of the error cases, right? Like you can have like one global return, but you generally want to show specific stuff for specific cases. Bonus complication number 2, this one, which doesn't even render properly, is an actual proper real-world example that we use in our app for what happens when the app comes back from background, right? We need to do, like, you can't even read it, it's massive, right? But imagine how many ifs and how many, what the code would look like to implement a state machine, right? Or to implement code that has all of these branching paths, and like here's this little one that intersects like this. Don't know why, couldn't render somewhere else. It's like all these error cases, there's a massive amount, and that's just for checking if the current login session is still valid, right? Nothing else, right? So what's like possible problems, right? Some parts are async, some parts are sync, right? The code, if you write it with ifs, it's like error prone, really error prone. It's really hard to understand the flow of the code, right? So how stuff gets from one state to another state. It's really hard to change the flow of code, right? Because generally, you can't just move code around. You actually have to know what the code does to move it around properly. Well, that's true in most cases, but whatever. Right? It's really hard to test the code because if it's a really complex flow, You can test all the dependencies separately, but that doesn't really mean that the code works, right? If everything works in isolation, does not mean it works well together. Right? And it's also really hard to add more intermediate states, right? What if you need to add ifs in between other ifs? That ends up being really complicated, right? So possible problem meet possible solution, right? Basically, if it looks like a directed graph and acts like a directed graph, it probably is a directed graph, right? So why don't we just encode the graphs, right, that we've seen before, the slightly less complex example, in JSON, right? So you have the start, it loads the cache. Load the cache can go into two possible places. It goes to state loaded or no cached version. If there's cached version, it checks the app version. If it's valid, then logs in. If it logs in successfully, it shows the main page, right? We just encode simple data structure, right? Just 2 levels deep. This perfectly encodes that graph, right? But it doesn't do anything, right? I mean, it's just data. It's just JSON that has no meaning yet. But we can make one, right? We can easily make meaning for that. It's just a matter of traversing some code, right? A graph, right? But how? Okay, so let's go to this really simple example where I give the stupid example where we check the login and show an error, right? I'm just gonna pop over to my gist here to show the example. Is this visible? It's visible enough, I would say. Or can it be seen in the back? Bigger, bigger. It's Command plus, I think, right? Yeah. There we go. Yay. So this is what that simple case looks like. Oh, God damn it. Why can't I select? Ah, whatever. Right? You can see here. You can see this part, right? This is how you'd encode that simple finite state machine. Right? Check login. If it's valid, move on. Otherwise, error. Then you have some like simple functions to check if the login is valid. In this case, if the username is admin, then you go through, right? Most basic thing in the universe. Right? Although obviously you can make this more complex, right? And then for show login, you just console log or whatever, do a message, show the login. You do some stuff here to show it, and then you transition to the done state, right? Same for show error, right? So if we look at one of these, what do we have here, right? We have the state for the finite state machine and what transition it takes, right? So effectively, it calls this function. If it returns this, we go here. If it returns invalid, it goes here. We go here. That's it. That's the gist of everything. We create a little runner, and then we have a little recursive function that does also async stuff, and you can look at it at home if you want. It's not particularly important, right? Yeah. Does it go to full screen automatically? No, I have to click this button. There we go. Yay. Yeah. Okay. So what do we get if we write our code in that way, right? And I urge you to go to my gist on gist.github.com/boogie666, which will probably be available at some point. And look it up. But what do we get if we write our code separate, right? The flow control is separate from the code that executes each step. First of all, we get modular code, right? Just test that each state goes to the appropriate transition and you're good, right? And then all you have to do at most is make sure that the transitions are linked right, which isn't that hard to do. Because if it goes through the happy path, it basically works. Right? You get really good refactoring because you can just move the nodes around in JSON. You just take a JSON out of one part and put it onto the other part. Right? You can add intermediate steps easily. But most importantly, in my opinion, you can visualize the code like this. Right? So these graphs that I've done were actually generated. I wrote this nice little thing using GraphViz, a library called GraphViz you can find on Node that can actually generate these graphs really nicely. And you get really good understanding as to how the flow of a particular thing works. Right? I think this is actually the most important thing you get if you write code if you basically define stuff as graphs, right? If you define it as it should be from the start, you can understand it much, much better, right? So basically, yeah. Thanks for listening.